Hello and welcome back to Chapter 22, video number 3 for AP Chemistry. Last time we left off looking at this structure here, and if you recall, organic chemistry is the naming of compounds that have a bunch of carbons and hydrogens together. What did we call this ring? A benzene ring. So we would pick one of these guys to be number 1 and count off from there. Well, we better pick number 1 as the guy that has the lowest alphabetical name. And if you recall, let's see if it says it in here, we have our benzene. What are our substituents named? Well, the ones over here by our 1 are an ethyl group. And then we count around 1, 2, 3, 4. And by number 4, we have a methyl. So we would name it 1-ethyl. 2, 3, 4, 4-methyl benzene. Or we could have named it para-ethyl-methyl-benzene because para means 1 and 4. Or for short, we can say p-ethyl-methyl-benzene. Sounds crazy either way, but the first one is probably the most accurate way to name it and the most common. Okay, so what about this guy? We have 2 bromines here coming off of a benzene ring. This is just another way to draw a benzene ring. So what we would do here is say which ones it's coming off of. Number 1 here, well, benzene's our parent name. And we have some substituents coming off of numbers 1 and 2. So we would call it 1,2-dibromobenzene. What else can we name it? Ortho-dibromobenzene or O-dibromobenzene, because ortho means first and second carbons. Alright, so some important benzene information here. An important derivative or structure that has benzene in it is what we call toluene, which can also be called methylbenzene. This is important because it's often a part of a bigger chain. So if benzene is used as a substituent off of a longer hydrocarbon chain, which by longer we mean 7 carbons or more, we call it a phenol. Recall phenolphthalein, the indicator that turns pink in bases? Well, phenolphthalein is just filled with these phenols that are either looking like this guy or have even more carbons attached to them. So here's an example. If we were going to name this guy, we would say, well, it's longer than 6 carbons. This makes it a 7-carbon chain, but we need to go off of our top guy here. So our parent name here is going to be associated with this long chain, 1, 2, 3, 4, 5, 6, 7, 8. What do I name something that's 8 long? Octane. So then I need to look at my substituents. Well, technically this guy's my substituent, and what's he called? Well, you would say benzene, but because he has this length coming off of him here, that makes it a phenol. And what number is it coming off of? If we start here, it's coming off of number 3. Remember, we start from this end because it's the shortest. If you went down here, it would be too long. So 3-phenyloctane. And there's not really another way to name that guy with our paras and orthos that we talked about before, because there's only 1 coming off of our benzene here. Now there are a bunch of other functional groups, and all a functional group really is a specific arrangement of atoms that we give a certain name to. And you'll eventually have to memorize all these in organic chemistry, but they don't necessarily go by these names. They usually have common names, but these will be important to know in an organic chemistry class. So here's just a little list of them. Halohydrocarbons, which we talked about, haloacids, which is a halogen bonded to something. Okay, and the general formula would be R over here, which represents any length of a carbon chain. Oh, I forgot to put that in there. So any length of a carbon chain is what R represents. It could be 1 long, 2 long, 8 long, doesn't matter. Bonded to a halogen, which is what the X represents. We would call that a halohydrocarbon. Then we have alcohols. You're pretty familiar, I think, with alcohols having OHs coming off of them. Ethers have an O in the middle with two things on opposite sides. Aldehydes, like formaldehyde, if you recall in biology dissecting something that smelled weird, it had formaldehyde. That's what it soaked in. We have ketones. These guys have groups on each side of a carbon double bonded to an oxygen. Carboxylic acids, which are real important to our livelihood, have a group that's bonded to a carbon with a double bond to an oxygen as well as a hydroxide. And then we have esters, which you can see their structure here, two oxygens, one is double bonded, and amines. Amines are probably the easiest to remember because they have nitrogen in there, and you really don't see nitrogen too often when we're talking about organic chemistry. So if we were going to name one of those halohydrocarbons or halohydrocarbons we talked about before, they're going to contain a halogen, and all we do is use that prefix. When before you were used to saying fluoride, chloride, bromide, iodide, now you're putting them at the beginning and saying fluoro something, chloro something. And you have to say which number of carbon it's attached to, of course, just like we have been doing the whole time. So here's an example for us, and there's a bunch of them in there, so we need to think about where they're located. And to do that, first we need to figure out how long this guy is. He has 1, 2, 3, 4, 5 carbons, so our parent name here is going to be pentane. And now I need to talk about where things are located, but recall I have to put them in alphabetical order. So who would come first? Fluorine, bromine, iodine, chlorine, bromine. And he's on number 2 here. So we're going to have 2, well, we're numbering them all out. We're going to have 2 bromo. Here's our bromine. And what would come next would be chlorine. Remember, we don't use our prefix when we're talking alphabetical. Well, we have 2 chlorines attached to the 5, so we would say 5,5-dichloro. Then what else do we have? We have 2 fluorines attached up here to number 1. So we say 1,1-difluoro. And last but not least, we have iodine, 3-iodopentane. So we come out with 2-bromo, 5,5-dichloro, 1,1-difluoro, 3-iodopentane. That's crazy, but it could happen. Alright, how about alcohols? Well, like I said before, alcohols have a hydroxide group attached. They can be considered primary, secondary, or tertiary, depending on where that carbon is attached to that hydroxide. And to name alcohols, we use the name of the parent alkane and drop that E and add an OL at the end. We also want to specify the position of the hydroxide with the smallest number, just like we've been doing the whole time. So here's an example for us. First, we need to look at how long this guy is. Oh, well, he's got 4. So he would normally be butane. Well, what did it say to do back here? We're going to take our butane, drop the E, and add OL. So it turns into butanol. And we need to say which one our hydroxide's coming off of, which is number 2. So it turns into 2-butanol. How about this one? Pause it, take a second, try to answer it. Well, it's 3 long, so it's going to be propane. But we need to change our ending to enol, so propanol. And we have 3 where our OH is coming. Oh wait, we need to make this the lowest number. So this has to be 1 actually. We're going to have the chlorine on our 3rd carbon because we're going to go backwards here. So 3-chloro, 1-propanol. Let's see if I was right. Yep, 1, 2, 3. 3-chloro, 1-propanol. So always start by your hydroxide. How about this one? Well, we need to start close to our hydroxide, so start on this end. We need to see how long it is. 1, 2, 3, 4, 5. 5 would normally be pentane, so we need to change it to pentanol. And our hydroxide's coming off of number 2, so the end of our name is going to be 2-pentanol because that number always comes right before where the final name is. But before that, we need to talk about our groups here. What's this guy? This is a methyl, and we have a bromo here. So first up, we're going to have 5-bromo, then we're going to have 2-methyl, 2-pentanol. Okay, so now we can talk about whether it's primary, secondary, or tertiary, and it all has to do with the carbon it's attached to. So on this guy, how many carbons is this carbon attached to? 2. That makes it a secondary alcohol. On this one, how many is this guy attached to? 1. That makes him a primary alcohol. On this guy, how many is this carbon attached to? 1, 2, 3. He's tertiary. Okay, so now we're professionals at naming alcohols, and we need to move on to aldehydes. Aldehydes always contain this carbonyl group, which we call this carbon double bonded to an oxygen with a hydrogen coming off of it. This functional group's always at the end of a chain. It has to be, because hydrogen can't bond to anybody right now, and neither can oxygen, so it has to be at the end. So we never need to say where it is. We know it's going to be at the end. And to name these guys, we just drop the E at the end and add an AL. So, for example, we have this guy. He is 1, 2, 3, 4 carbons long. He would be butane. So, if he were butane, we just change our ending to butanol. Pretty easy. Okay, how about this guy? He's 1, 2, 3, 4, 5, 6 long. 6 would be hexane, so we're going to change it to hexanol, but we have something else here we have to account for. Don't forget this little iodine. He is considered to be on the 4th carbon. We started from this end because that's where our aldehyde is. If we started here, it would have been 3, but technically we should start from where our aldehyde is. So he's on the 4th one, so we're going to have 4-iodohexanol. Pretty easy. Okay, so what if it was a ketone? Well, ketones, the only way they're different from an aldehyde is they don't have that hydrogen. That means these guys can bond wherever they want to, in the middle, at the end, doesn't matter, because they can have something on each side. And to name these, we just use that same parent name, but drop the E and add "-one" at the end. So we also have to say where it's indicated, since it can be anywhere. And we could also name each of these R groups as a substituent, followed by the word ketone if we wanted to. So there's always a second way to name it in the organic world, it seems like, and that has a second option. So let's try this guy. He is how many long here? 4. And because he's 4 long, that would normally be butane, but we changed the N to "-one, so we have butanone, rather. And which one is our carboxyl coming off of here? The second one, because we want to go the shortest distance. So we would name it 2-butanone. But we could also name those substituents coming off of it, like I mentioned, and we would just call that an ethyl methyl ketone, because this is an ethyl and this is a methyl. So 2 ways to name it. How about this one? It's 1, 2, 3, 4, 5 long, so it would be pentane, but we change it to "-one, so it turns into pentanone. And this guy's coming off number 3, so we could name him 1, 2, 3 pentanone, or we could name him diethyl ketone, because there's 2 ethyl groups coming off of our ketone, so diethyl ketone. Now what if it's an ester, or an ether rather? If we're naming an ether, it means it contains an oxygen single bond that's just in the middle of our element. And to name these guys, we name each as a substituent and follow it with the word ether. If there's 2 of them, we say di out in front. So we'll try this guy. All we're going to do is look at this oxygen in the middle. That tells us it's an ether, and we need to know what's on each side. Well, it's 3 long, so it's going to be a propane on each side. So we call it dipropyl ether or ether. Try this one. Name each substituent here and follow it with the word ether, and I'll tell you in the next video how you did.